All right, now let's move on to action potentials. So first off, I want to just show you what's going on here in this figure. This is a typical action potential. We're going to be talking about this a lot in this set of lectures. But this is a typical shape for an action potential, and we're going to, again, talk a lot about what underlies that shape. I want to remind you that action potentials travel. This is not a reminder. I want to tell you that action potentials travel down the axon of a neuron. So that's this electrical signal shown here in this diagram right here. Okay, so let's go over some of the characteristics of action potentials. First of all, action potentials generally occur in axons. Okay. Action potentials are always depolarizing. So they're always going to go up like this. They're never going to go down and then back up. They're always going to be depolarizing. They're what we call all or none, meaning you either get this whole thing or you get nothing at all. Okay, so it's always going to be the same size and shape in a given neuron. So remember when we were looking at graded potentials, you got different sizes of graded potentials depending on the size of your stimulus. That is not true for action potentials. With action potentials, they're always going to look exactly the same in the same neuron. Okay, same size. Bigger stimulus, same size action potential. Smaller stimulus, as long as it reaches a certain level, same size action potential, same shape. Okay. Action potentials cannot be summed. That kind of follows from this all or none principle, right? So you have either get the whole thing or you get nothing. If you add two of them together, you still get the same thing, okay? All right, and then finally, there is a minimum stimulus required to trigger an action potential. So I won't go into great detail here. We'll cover it in the following sections, but remember with graded potentials, you have a little stimulus, you get a little graded potential. You have a bigger stimulus, you get a bigger graded potential. With action potentials, that is not true. You put in a small stimulus, you get no action potential. Slightly larger stimulus, no action potential. Larger stimulus, once it reaches a certain level, then you get the entire thing, the whole action potential, okay? All right, so that basically covers the differences between graded potentials and action potentials. Let's review. So does each of the following describe a graded potential or an action potential? One usually occurs in the axon, all or none, signal strength degrades with distance, and finally can be summed. So why don't you go ahead, hit pause and answer those questions. Okay, so hopefully you were able to do that. I'm just going to go over the answers here. So usually occurs in the axon, that's an action potential, all or none, that's an action potential. Signal strength degrades with distance, that's a graded potential. Can be summed, that's a graded potential, okay? All right, I'm not going to go over this table, but I just want to draw your attention to the fact that it exists. Okay, so you do have this table in your book that kind of summarizes the differences between graded potentials and action potentials. I didn't go too much into some of these details, so don't worry about those, right? Okay, so that wraps up this little section here of graded potentials versus action potentials. Here are your learning goals. Here is your vocabulary, not a big list. See you next time.